Today, we're going to look at the replacement of a scroll compressor on an outdoor residential air conditioning unit. Before starting, we ask the homeowner to clear away the vegetation around the unit. This allows for better airflow through the condenser and helps to keep the coil clean from dirt and debris. The net result is to lower the condensing pressure, as the unit does not need to work as hard to reject heat, and that can mean substantial energy savings for the owner. Once the power is shut off and checked with a voltmeter, the process of reclaiming the refrigerant charge from the system can proceed. It's mandatory to remove the refrigerant from both sides of the system. Remember to never mix different refrigerants together in the same reclaim tank. In this case, the technician is using a single-use type of reclaim cylinder to avoid this possibility. To determine how much refrigerant was removed from the system, weigh the empty reclaim tank, and then weigh it again once the reclamation is complete. The difference will be the net weight of refrigerant removed. Most scales have the function built in to make it easier. While the reclaim unit will remove the vast majority of the refrigerant, a slight positive pressure will remain. Here, the technician is checking the pressure remaining in the system by reading the pressures on the manifold gauge with the reclaim tank isolated. Once the reclamation is completed, work can begin on changing out the compressor. While the system is open, it's a good idea to replace the filter dryer, or as in this case, install one where one did not previously exist. This is important as no matter how much care is taken, some air will enter the system and it will contain moisture. There's also the possibility of dirt, oxides from brazing, and copper grit entering the system. This dirt will need to be removed to protect the valve and compressor. To install the filter dryer, the technician first checks the diameter of the tubing to verify size. He then measures the length of tubing that needs to be removed to accommodate the dryer. Next, he cuts out and removes the correct length of liquid lines. Once this is done, he cleans the tubing and dryer connections. It's always good practice to purge the system with nitrogen to force out any air that may be present. Because nitrogen is an inert gas, it will greatly reduce the oxidation of the copper when heat is applied. It's important not to actually pressurize the system with nitrogen during brazing, as this may forcefully eject molten brazing material from a joint. During brazing, be sure that the brazing material completely wicks around the connection to ensure it's leak-free. If the dryer connection size does not match the tubing size, the use of an adapter fitting is recommended. Once the dryer is installed, it's time to focus on the compressor. Inspect the terminal box and the unit's electrical box to look for burnt terminals, conductor damage, dirt, and debris. Once the conductors have been removed from the compressor, unsweat the discharge and suction connections. Here, the technician is gently tapping the discharge line to remove it from the compressor. Once the discharge and suction lines have been disconnected, the mounting bolts can be removed and the compressor pulled out of the unit. Do not use the compressor terminal box to lift the compressor. Once the old compressor has been removed, the new Danfoss compressor is mounted inside the unit. The suction and discharge lines can now be fitted. Some minor adjustment of the tubing position may be required, but it's minimal as you can see. The technician is fitting the suction line into the compressor. He cleans the connector and tubing to remove any contaminants, being careful to limit the amount of grit getting inside the connector. Once again, if not already done, a purge of the system with nitrogen will reduce the oxidation of the copper. Once in place, the suction line is brazed to the compressor, applying the torch to all sides of the tubing and joint to ensure even heat and solder flow. A light tapping of the line will help to fully seat the tubing if there is any brazing material remaining on it. Once completed, the joint should be inspected to make sure that it's fully covered and that there are no holes or gaps present. Once the suction line has been brazed in, the discharge line should be connected. Use the same procedures as were used for connecting the suction line. Now the system should be evacuated to remove any air and other non-condensable gases that may be present. The system can be pressurized with nitrogen prior to evacuation, and this will aid in drying the system. It will also ensure that moisture is removed. Make sure the vacuum pump is connected using a good set of manifold gauges to both sides of the unit, so you're drawing from either side of the compressor and TXV. This will ensure that you achieve a proper vacuum everywhere in the system. While the system is being evacuated, The technician uses the time to clean out the unit with a shop vac, removing leaves and other foreign debris. This is especially important for the electrical box, which in this case is fairly dirty. This will help to avoid problems with the relay and other electrical components. If the condenser coil is dirty, wash it off with a garden hose and remove all of the dirt. This allows the system to run cooler, saving energy and money for the homeowner. Compressor manufacturers recommend replacing the contactor when replacing the compressor. This is considered good practice as it ensures proper electrical control of the compressor and fans for the life of the new compressor. It's cheap insurance as there may be damage to the contactor that is not readily visible to the naked eye. Hidden damages can shorten the life of the replacement compressor. It's also recommended that the capacitor be replaced or at least tested to ensure that it's in good working condition. The technician inspects the conductors and notices there's a discoloration of the insulation. He trims back the conductors to remove any areas that may have been degraded near the connections to the old relay. He then fastens them to the terminals of the contactor and inspects and fastens the control wires to the coil. While the evacuation has been underway, the technician has been monitoring the progress on the manifold gauges. He does one final check on the manifold gauges by closing the connection to the unit and comparing the vacuum with the pump alone in the system, and notes any deflection. If the unit was open to the air for an extended length of time, and especially if it contained POE oil, it's necessary to utilize a micron vacuum gauge to ensure that a suitable vacuum has been obtained to remove any moisture that may be present. This would also be required if the unit was equipped with a sight glass that was showing moisture was present by displaying a yellow indicator. Before charging the unit, the technician attaches the conductors to the appropriate terminals on the compressor using the supplied template or the installation guide as reference. Once the evacuation is complete and the system is deemed leak-free due to the pressure test holding for a suitable period of time, the pump is removed from the system and the technician prepares to charge it. He sets up a new container of R22 on the weigh scale, makes sure the ammeter is clamped on, and does one last quick inspection of the system to make sure nothing has been missed. The technician places the door back on the indoor unit, but does not fasten it completely so that he can inspect it for proper refrigerant distribution into the coil if desired. The technician next weighs in the refrigerant charge, checking subcooling to ensure that the proper amount of refrigerant is being added to the system. If a TXV is being utilized, or to measure the value of superheat present, if the unit is equipped with a fixed orifice metering device. For subcooling, he does this by measuring the temperature of the liquid line and comparing it with the saturation temperature derived from a pressure temperature chart. For superheat, he measures the suction line temperature and compares it to the saturation temperature. If possible, always refer to the unit manufacturer's recommendation for subcooling or superheat values based on the measured indoor and outdoor conditions. Once charging is complete, the technician may go back to the indoor unit to inspect the distributor and coil. He's looking for any signs that the distributor tubing may be frosted due to poor refrigerant flow caused by oil logging or other blockages. Once this check is complete,